All right, so let's deal extensively with alkanes. The alkanes, also called paraffins, this way, also called paraffins, are desaturated hydrocarbons. Are desaturated hydrocarbons. Are the saturated hydrocarbon atom, or hydrocarbons, please. Sorry. Hydrocarbons, please. Full stop. All the carbon atoms in an alkane, all the carbon atoms in an alkane molecules are sp³ hybridized. I hope you understand what that one means. Good. So you now see why I had to lay that foundation. Assuming I didn't like how, what is sp³? But now you understand the concept. That's why I had to lay that foundation in our previous class. All the carbon atoms in an alkane are sp³ hybridized, full stop. Are sp³ hybridized, full stop. They have the general molecular formula CnH2n plus 2. They have the general molecular formula CnH2n plus 2. CnH2n plus 2, full stop. And the simplest member of the alkane family is the methane. And the simplest member of the alkane family is the methane. Methane this way. Methane this way. Please check what we did how to name compound. For met, carbon is how many, please? How many carbon for met? We said 1. So look up, please. This same formula, please, put N as 1. It becomes C perhaps 1, H into 2 times 1, of course, 2N becomes 2 times 1 plus 2. That gives you C, here's 1, it goes up, that's C, into H, 2 times 1, 2, plus 2, 4. So I have CH4. If I want to write this one here in structural form, it becomes C bonded to 4 hydrogen. That becomes 1, 2, 3, 4. So this is methane. This is methane. The second one there is ethane. For earth, we said you have 2 carbon, so C is 2. If C is 2, using this formula, I have C, N becomes 2, so 2, H into 2N becomes 2 times 2, so 2 times N, that's 2 plus 2. That gives you C2, H into 2 times 2 is 4, plus 2 is 6. Draw this structure. I'm having C2, 1, 2, H6, 1, 2, 3, 4, 5, and 6. So this is like the basic idea. I'm breaking down this one to the very simplest form, and then we'll build from there. The first member, methane. Second member, ethane. So you can continue and get propane and etc. But let's proceed. Give it 1 line space, take a paragraph. 1 line space, take a paragraph. Alkanes can be represented using strokes. Alkanes can be represented using strokes. S-T-R-O-K-E-S. Strokes. On the board can be represented using these strokes. So this. Only, add only there. Alkanes can be represented using strokes only, including the alkyl group. including the alkyl group. Including the alkyl group. Example. So this is an organic compound, and this is an alkane. Because if I look at this, I have just single bond throughout. What's the name of this compound? So look up, please. How do you get this stuff? What do? It's as easy as this. For each of the sharp edges, you assume there's what there? A carbon there. That's it. So I'm having here as a carbon here, 1 carbon, 2 carbon, 3, 4, 5, 6, 7, 8, and then 9. For 9 carbon, what do you have there? Is a non. And since it's a single bond, it becomes an alkane. So it becomes what there? A nonane. So this compound is a nonane. That's how it's done. The compound there is a nonane. Example 2, please. All right. Example 2, please. We have this. Example 2, please. We have this. Let me assume that you were all in my former class, my previous class, we did how to name compound. I won't start stressing myself with this alkane ethyl stuffs. But let's get to name this compound, please. So when it comes to naming compound, first of all, skeletal structure, looking through all of this, they are all single bond. There's no double bond. There is a possibility, let me stress here, of something of this nature. If I something like this, I know, something like this, it can possibly exist. So let's tell you what there, an alkene. But don't worry, it's not here. So it's just single bond throughout. So it's an alkane. All right. So task 1, get longest continuous carbon chain. Let me label all the ends. I'll label the ends. Let me call this A. Let me call this B. Let me call this C. Let me call this D. Which of them would give you your longest continuous carbon chain? A to B, A to C, A to D, B to C, B to, which of them? Please check. Longest continuous carbon chain from where to where? From A to D, obviously. From A to B is 1, 2, 3, 4, 5, 6. A to C is 1, 2, 3, 4, 5, 6. Same thing. A to D, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think any of them is longer. We're assuming that A to D is the longest continuous carbon chain. So I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 1, number of carbon atoms, 9. That gives you nonane or none. Number 2, root 2. Look out for the functional group. Here is a single bond. It becomes what there? An alkane. Number 3, I'm getting substituent. I'm doing my numbering. Let's number from A to D. If I number from A to D, I'm having 1, 2, 3, 4. So that means from A to D, I'm having 1, 2, 3, 4. This one becomes automatically a substituent. I've said before, a substituent, of course, I expect that I'm having carbon atom here and carbon atom here. But then this one will become a substituent. Why? Because it is not part of what? The parent carbon atom. So automatically, this is a substituent. This one too is also a substituent. So if I number from A to D, I'm having 1, 2, 3, 4. This one is at 4 and then 5. This one is at 5. If I number from D to A, I'm having 1, 2, 3, 4, 5, and then what again there? 6. I said choose the least. The least has to be what there? 4, 5. So I know where I'm taking from. So I have this. Number 2, what is the substituent? Now here's how it works. Whenever you have just one stroke that is outside the parent there, your one stroke means 1 carbon atom. A 1 carbon atom substituent is what there? Look at this. If I add 1 carbon here to make this, okay, this is not a substituent though. Okay, fine. So let's do this. Let's do this way. Carbon 1, 2, 3. Fine. So this one becomes a substituent. A 1 carbon atom substituent. If I want to balance this one up, it becomes 1, 2, 3, 4. In other words, a 1 carbon atom substituent is what there? C1, 2, 3, H3. What's H3? Methyl. All right. So a one carbon atom substituent is a methyl. So this one becomes methyl. If a one carbon atom substituent is methyl, what will 2 be? Ethyl. So this one becomes ethyl. So name this compound. What will it be there? So hold on. I stressed something about this in last week, if you can remember. I said when it comes to organic, this is an organic substituent. Which do I pick first? Do I pick from alphabetical order or position? I said depending on your author. So I said some authors will say use alphabetical order. That becomes E before M. Some will say use what there? Position. That becomes what there? Methyl before what there? Ethyl. But let's go with alphabetical order, please. If I go with alphabetical order, I'm taking ethyl before methyl. So this compound becomes what there? So I'm having 4 ethyl hyphen 5 methyl what there? No name. Please confirm. Is something wrong with the way I wrote the formula? Check. I told you something about how to write the names of compound. Check very well, please. Is something wrong with the way I wrote the name of the compound? Check. Yes, which part? Where? Huh? After methyl. After methyl, what happened to this? It's correct, Nabi. We said number alphabet. What there? Hyphen. Alphabet number hyphen. Number alphabet hyphen. Then combine these ones. And I said you only use capital letter when it's what there? Starting the name. It's not starting, so it's correct. Yes. I got that too. From here now, I said if it's one, look up. I said if it is one substituent, it's methyl. Like, look up, please. Let me do it this way. Longest continuous carbon chain is this one here. From A, like this, we said this one here is longest continuous carbon chain. This is my longest continuous carbon chain. That's this one here. What do you observe? Observe that this one is outside. It's not part of it. Also observe that this one too is outside my parent carbon atom. So hence, this one and this one becomes what there? Substituent. And I said when you have one stroke substituent, that becomes a methyl. When it's two is what there? Ethyl. That's the idea. That's the idea. All right. Your task, please. Copy down and name this compound. All right, please, very fast, please. Copy down and then very fast, please. Look very well. I have a bromine. Why are you skipping the bromo? You did not see this thing. You write the name correctly. Check. You didn't write the name correctly. You're having alphabet and number. You didn't use the hyphen, so you're wrong. Let's name this. The bromine is clear here. Oh yeah, look up. Look up. Look up. Let's name this compound. First things first, longest continuous carbon chain. Without stress, I can see it's from here to where there. This one here. Abby? Yes. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Is any longer? 1, yes? 1, 2, 3, 4, 5, 6, 7, 8. It's no longer now. That's the longest, Abby? Yes. From here, A, till here, D is my longest continuous carbon chain. This one is not part of it. This one here is a substituent. What substituent? Please, how many steps do you have here? 1, 2, 3. If 1 is methyl, 2 is ethyl, 3 becomes what there? So here is propyl. That's case 1. Next up, 1 stroke is what there? Methyl. Another 1 stroke here. Methyl. Another 1 stroke here. That's methyl. Now listen. One of the rule there, I think that was rule 4 or rule 5. It says for a combination of inorganic substituents like the halogen and organic substituents like the methyl propyl. Please, which one is considered first? Is it inorganic or organic? Inorganic. So I'm taking bromine first. Using my eyes, I know that if I number it 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the best way because it gives you 2 to bromine. So rule 1, longest continuous carbon chain 9. That's a non. Rule 2 is we said functional group is a single bond. So because what there? An alkane, single bond. Rule 3, I'm doing the numbering, which I've already numbered here. So how do you name this first? So it becomes 2 bromo. Please observe the way I'm writing numbers and letters. Most of you didn't do that way. I said number letter, use a hyphen. 2 bromo. What's next? 3, 4, 6. How do you write it there? Hold on. Yes, but how can you write it correctly? So because what there? 3. What's next there? Comma. 3, 4, 6. Hyphen. Next up, trimethyl. Okay. This one is here. So it becomes hyphen. Position 5. Propyl non-name. So the name there is 2 bromo, 3, 4, 6 trimethyl, 5 propyl non-name. That's the name. Who got it correctly? Sit there. The Englishman would say general methods of preparing alkanes. The chemist, being old in his English vocabulary, would now say general method of preparation of alkanes. What is stress? General method of preparing alkanes is much more modern and formal as compared to general method of preparation of alkanes. What are the off for? How many off in one sentence? Anyways, number one, please. So how do you prepare alkanes? Number 1, please. Hydrogenation of alkenes. Please note these things. This is where it gets serious. Hydrogenation of alkenes. Take down, please. What is hydrogenation? The addition of what? Hydrogen, that's all. Hydrogenation is the addition of hydrogen molecule. Hydrogen molecule, is it H, H2, H plus or H3? In bracket, H2. Hydrogenation is the addition of hydrogen molecule, in bracket, H2, to a compound. Full stop. The hydrogenation of an alkene results in the production of a corresponding alkane. The hydrogenation of an alkene results in the production of a corresponding alkane. Full stop. The equation of the reaction is given below. The equation of the reaction is given below. So please copy this, please. All right. So this is your general, your general formula or equation of the reaction is this. So an alkene combines with hydrogen, that's hydrogenation, under the influence of PT, PD, and Ni. PT is called platinum, PD is palladium, Ni is nickel. Three of them are your choice catalysts for this reaction. What's the catalyst? What's the catalyst? That speeds up. Yes, you're correct. Yes, you're correct. Yes, you're correct. Yes, you're correct. Now let me talk. Let me talk now. So a catalyst is what there? A substance that does what there? Speeds up the rate of what? A chemical reaction. By doing what there? Reducing the what? Energy barrier or activation energy. Catalyst. All right. So you have the choice catalyst in the hydrogenation of alkenes is platinum, palladium, or nickel. Any of them would work. So I have this. Example, please. So let's use n as anything there. Use n as anything there. Let's take 3, n3. Let's take n as 3. If n is 3 here, this becomes C3 plus 2 times 3 is 6 plus H2 gives you C as 3, C3 into H. 2 times 3 is 6 plus 2 is 8. So C3, H8. I have this. This one is it balanced? Yep. 3 carbon here, 3 carbon here, 6 plus 2, 8 here, 8 here. So this is correct. You what? Okay, catalyst. Pick any one. Then let's use PD, palladium. So you don't use 3 of them, oh. Except what the reaction to happen like flash. Phew, it's done. Please use only one, no. Use only one catalyst, please. Don't go and put 3 of them. Okay, fine. Still, if you want to do the broader sense, you can now say PT, PD or Ni. But if you don't go and combine all 3 or more, it's happening before your eyes. Anyways, so this is this. Let me show something just once and we proceed. In some questions, they will ask to draw the structural, what's it called? Reaction. By structural reaction, they mean draw this one in full. This in full, this man here is an alkene, so expect a double bond. So it becomes C1, C2, C. Add double bond in any one you want to. That's here. Try to balance this. This one has 1, 2, remaining 2 more. That becomes 3, 4. Balanced. This one has 1, 2, 1, 2, 3. This one here, 4. This one has 1, 2, 3, and 4. Observe C3, 1, 2, 3. H6, 1, 2, 3, 4, 5, 6. That's correct. Plus H2 to give you C3H8. 1, 2, 3. It's an alkane now. So single bond. Balance it up. 1, 2, 3, 4. Balance. Come to this. 1, 2, 3, 4. Balance. Come to this. 1, 2, 3, 4. Balance. C 1, 2, 3. H 1, 2, 3, 4, 5, 6, 7, 8. It's correct. This one here is 1, 2, 3. That's a prop. Becomes prop 1 in or just propene. I'll tell you what is a 1. There can be no prop 2 in. I'll tell you why. Oh, substituting propene. Prop 2 in does not exist. I'll tell you why. This one now becomes 1, 2, 3. Prop 1, 2, 3. Propane. The way the guy shouted the pain, I felt like he was in pain. No, honestly, pain. Like, all right. So here's what we said. Here's what we said, please. We said that the my catalyst PD palladium. Please, we said that the hydrogenation of an alkene gives you a corresponding alkane. Please don't go and hydrogenate propene and get butene. It doesn't. It's not like that. If it's propene, you get propane. If it's non one in, you have what there? Non-name. Don't go and do one side opt, one side boot. You're your own. No. Number 2, please. So this is the molecular formula. This is the what there? Structural formula. All right. The second method of preparing alkane, number 2, is the reduction of alkyl halides. Reduction of alkyl halides. Alkyl halide. Alkyl, an alkyl group, methyl, ethyl, propyl, halide, a halogen, bromine, fluorine, iodine, whatever. All right. Take that, please. That is I point E. That is I point E Rx. That is by alkyl halide, you mean Rx. That is Rx. So alkyl halide is represented by Rx. That is Rx. Where X is a halogen. Where X is a halogen. Where X is a halogen. That's fluorine, bromine, chlorine, or iodine. And R is an alkyl group. R is an alkyl group. Methyl, ethyl, propyl, etc. etc. Paragraph. In these reactions, in these reactions, the halogen in bracket X. In these reactions, the halogen in bracket X of the halide, the halogen of the halide is replaced by hydrogen. Is replaced by hydrogen. This can be done in 2 ways. This can be done in 2 ways. The first way is called the hydrolysis of Grignard reagent. This one is called the hydrolysis, or it's on the board there. This can be done in 2 ways. The first one is called the hydrolysis of Grignard reagents. Please asterisk this one. This is one of the most important that they always bring out in the exam. So please asterisk this one. if you compare my notes to your text, there are more equations on your text. I formed the note myself. So this note is formed by myself. What I did was simple. I went through all your past questions. The most repeated ones, I used them as a note. That's what I did. So please, also I'm showing you here, they are very, very important. So one of the ones you should note is this Grignard something. Please note this equation. It comes out frequently. All right, what's Grignard reagent, please? Let's look at this, please. Take down the equation of the reaction. The equation of the reaction is given by the equation of the reaction is given by this is given by this given by this is given by this. So you have this, the alkyl halide combines with magnesium to give you a Grignard reagent, which passes through water to give you an alkane. Give an alkane. Example. I want to clean this stuff off, please. I want to clean stuff off, please. So please don't forget, this is actually Grignard reagent. Okay, let me write it here. Let me see if I can. Now listen and listen carefully. I want to take R. We said R is any alkyl group. I want to pick R as, for this case, CH3, that's methyl. I'm picking any of the halogen, that's chlorine. Combine these two. They said place the R first, so it becomes CH3 and then X, chlorine, that's Cl. Please, R, methyl group or alkyl group, I'm using methyl now. X, I'm choosing chlorine. Combine with magnesium. The combination is not as straight as it looks here. In the actual sense, magnesium is playing not a major role, but a minor role. So more like saying, I am passing this through magnesium, not really a direct combination. I will now have the say R first. The R here was CH3, so it becomes CH3. They said magnesium, Mg. They said the X should come next. The X here was chlorine, so Cl. Pass it again under the influence of water, H2O, or perhaps steam, if that's in what's it called, gaseous mode. Then the R there, CH3, and then H, that's H. If I combine in total, how many hydrogen here? So it becomes CH4. So this is what is called Grignard reagent equation. Now listen. They will also ask to draw the structural form of this. In structural form, what will it be? CH3, so it becomes this 1, 2, 3, and then chlorine, yeah, Cl. Combine this again with magnesium, that's Mg. It gives you this one here, C, 1, 2, 3, MgCl. I'm having MgCl, magnesium chloride. And then pass it through the influence of H2O. It gives you CH4, C, 1, 2, 3, 4. They'll now say you should name each of the terms here. This one here, now listen. This is called an alkyl halide. Alkyl. The alkyl here is methyl, so it becomes methyl halide. The halide halogen in quotes here is chlorine halide chloride. So methyl chloride. So alkyl halide, methyl chloride. Next up, this one here we said is called Grignard reagents. All right, this is called Grignard reagent to give you what here? This is methane. So this is how this man works, right? Multichloride, Grignard reagent, methane. So you have this case. All right, let's proceed, please. Example, copy and complete the reaction below. Example, copy and complete the reaction below. All right. So this is how it comes up in the exam. Copy and complete the table below. The reaction below. You have this. Can you attempt it? So try it up. Let's see. For your answer, simply compare this with the general form Rx. For here, R is what there? CH3, CH2. X is what there? Br. So it's simply this. What should be here? Magnesium. Please, magnesium is a key part of the Grignard reagent equation. So what should be here becomes Mg, magnesium. What should be here? They said use your alkyl group with magnesium and then your halogen. So what will be here now? The alkyl group is this CH3, CH2 with the magnesium, that's Mg, and then your halogen, that's Br. This is called what there? Grignard reagents, water, and this. So this is how you complete this table. The question now is this: what if you don't remember Grignard reagent form on your own? OT law, it's gone. So the second one there is reduction by metal and acid. Reduction by metal and acid. Take down, please. The equation for the reaction is given below. The equation for the reaction is given below. So please, the idea for this one is that I'm having an alkyl halide. In this case, what's my alkyl here? What's the alkyl group here? 1, 2, 3, 4. That's what there. Butyl. What's the halogen here? So because what there? Not bromide. Bromide. Not butyl bromide. What's butyl bromide? butyl bromide. It's not alkyl halide. Alkyl halide. What do you have there, please? Yes, what's a butyl? Butane. So the idea is simple, please. I'll pass an alkyl halide through a metal or hydrogen, and I'll have an alkane. So that's simple idea, please. Metal, hydrogen gives you a corresponding alkane. This is called the reduction of alkyl halide. And that's what? This one's here. Listen. Some persons are admitted to study chemistry. That means for the next 4 years of their life, what they'll be studying is what? Majorly chemistry. They are the ones that will now start asking, what does all of this mean here? Right? But in a broader view, if this is combined, we're saying that it will get to a point where the hydrogen somehow. So the question is this. I have this and this. So if I combine this with hydrogen and this, what happened to the bromine that was here? That's the question. The bromine that was here, what happens to this? In a broader view, at the end point, it becomes plus zinc bromide. 2, it becomes zinc bromide. Look up, please. Look up. And that's what this one is telling you. It's telling that at the end process, zinc will have 2 positive. The X is your halogen. That's bromine. Positive, negative, they will attract to form a compound, which is this. But then, this is, we don't need this one here. That's why I did not include this. So I left it out of it. But that's what this one is indicating. That aside from my alkyl hydrogen, which is my alkane, there will be another compound, which is zinc, Z2 plus or plus plus, and the halogen minus to form this one here. But then, this one here is your major product. This one here is minor. For now, we are ignoring minor. We are taking major. That's why you have Zn plus plus. But for now, don't worry about Zn plus plus. Focus on this one. That's what you need, please. That's it. All right. Physical properties of alkanes. So number 1, the first physical property, please. I said number 1, the alkanes from methane to butane are gases. Methane is a gas. Ethane is a gas. Propane is a gas. Butane is a gas. All right. Are gases at room temperature. Why the next 13? The next 13 will start from C5 to what there? All right. Why the next 13 from 5 to 17 are liquids? Are liquids? Are liquids? And those containing 18 carbons and more are solids. And those containing 18 carbon and more are solid. 18 carbon and more are solids. Your question last year was something like this. Your question last year was something like this. Said ethane and octane are gases at room temperature. True or false? The answer is what? False. False. Why false? Because this one here is a gas. This one here is what there? A liquid. So the answer is false. So came out last year. So please take me, please. The first 4, they are gases at room temperature. The next 13, they are liquids. Above 18, they are solids. Number 2, physical properties, please. Number 2, physical properties, please. Number 2, alkanes are soluble in non-polar solvents such as benzene. Alkanes are soluble. How do you call it? Soluble. Are soluble in non-polar solvents such as benzene and insoluble in water and insoluble in water or more. All right, so that's what we have, please. Next topic, please. Let's now look at preparation, reaction of alkanes. Next up, please. Reaction of alkanes. Let's look at reaction of alkanes, please. Alkanes undergo different reactions. Alkanes undergo different reactions as given below. Number one, let's consider the halogenation of alkanes. Number one, let's consider the halogenation of alkanes. If hydrogenation is addition of hydrogen, what's halogenation? Halogen. All right, example, I'll just go straight to an example. For example, I have an alkane, let's say methane. Combine methane with an alkane, with a halogen, please, C2, under the presence of heat and light. My product will be CH3Cl plus HCl. So I'll have this. CH3Cl is methyl chloride or chloromethane. Right, this one here. Methyl chloride. So we'll choose to call it chloromethane. Right, that's this. What's HCl? HCl, is it hydrogen chloride or hydrochloric acid? No. 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 What's between hydrogen chloride and hydrochloric acid? What's the difference? One. No, now. The major stuff there is the state of matter. HCl in liquid is an acid, hydrochloric acid. HCl in gaseous form is a gas, known as what there? Hydrogen chloride gas. The major difference there is in their state of matter. In this case here, what do you think it would be? Will it be the gaseous form or the liquid form? Like, think about it now. We said this is what there? A gas. Chlorine too. Right? So it's most likely hydrogen chloride gas. Not like I am too sure, but it's most likely because methane is a gas, as we said, at room temperature, chlorine gas. So it's most likely hydrogen chloride gas. That's it. This one is called methyl chloride or chloromethane. Let's continue, please. On further chlorination, that's this one here. On further chlorination, we get look at please. What do you call this? This is called a dichloromethane. Aha. One of those are refrigerants. This is what you will learn as refrigerants. It's called dichloromethane. Look up, please. This is how you draw the look up, please. This is how you draw the structure, please. Careful. This one becomes C here. H, then Cl, Cl. This is this. Alright? It's called dichloromethane. That's 2 chlorine and methane. It's called a dimethyl chloride or methylene chloride. On further chlorination again, I will now bring the dimethyl chloride combined with another chlorine. What do you think I'll get? Hello? What will it be? Try. It was 1 chlorine, chloromethane. It went to 2, dichloro. It's now go to 3, trichloromethane. What will be your formula there? CH, what there? Cl3. This becomes what there? Trichloromethane or chloroform. Or chloroform will now combine with HCl. This one becomes C, H, just 1 H, and then 3 chlorine. 1, 2, sorry, Cl1, Cl2, Cl3. It's called a trichloromethane. Please do another on further chlorination. Add it here. What do you get? Write down the formula and everything yourself, please, fast. So on further chlorination, last one, please. So what will you get there? CH, Cl3 plus Cl2. To give you what there? C, of course, hydrogen is now gone. From 3, it went to 2. From 2, 1. From 1, nothing is left. So CCl what there? 4. All right. Plus what there? What's the name here? Tetrachloromethane or what? Or chloroform. Sorry, or carbon tetrachloride. Sorry, or carbon tetrachloride. If you say draw the structural form of this, it becomes C 1, 2, 3, and 4. So this is called the halogenation of alkane. That is done from methane to methyl halide, dimethyl halide, tri-alkyl halide, please. It's dialkyl halide, tri-alkyl halide, tetrahaloalkane. That's what it should be, right? Haloalkane, chloromethane, dihaloalkane, dichloromethane, trihaloalkane, trichloromethane, tetrahaloalkane, tetrachloromethane. Moving on. Okay, before we move on, please, let's add something there. Let's add something else. Take down, please. The general form or equation, the general equation of the reaction, is given by please this, by this. Is given by, we have that. All right. The general reaction of the alkane of the halogen is fluorine. So for this case, the most reactive is fluorine, followed by chlorine, followed by bromine. Take note that if you're forming this, please do not use iodine. Why? Iodine does not react. So don't just start saying diiodomethane. Okay, it's not possible. Doesn't react. So the most reactive there is fluorine, followed by chlorine, followed by bromine. Iodine is not among. All right. So we're looking at reactions of alkane. The first one we said is called halogenation, not hallucination. Then hallucination is halogenation. Let's look at the second reaction of alkane called combustion of alkanes. Combustion of alkanes. When we say combustion, it means something. When we say combustion, it means something is burning in the presence of oxygen. Take down, please. The equation for the combustion of alkanes, the equation for the combustion of alkanes is given below. For the combustion of alkanes is given below. Is given below, so you have this. Given below, please. So this is the equation of combustion of alkanes. Let's use methane. For methane, for met, carbon is 1. So it becomes C1 or C, H into 2 times 1, 2, plus 2, 4, plus, you said N is 1, 3 times 1, 3, plus 1, 4, divided by 2, 2, 2, O2, to give you N is 1. 1 times CO2 is what there? CO2, plus N is 1, that's methane, 1 plus 1, 2, so plus 2 H2O. So if you check, this is a balanced equation. It's balanced. So the idea is simple. If you can remember this equation, put N as 1. It will automatically balance on its own. This is called combustion of alkane, methane. Methane, oxygen, carbon dioxide, water. It will balance up properly if you do that. So what you should do is this. If you want to, you can please note that the product of the combustion of alkane is carbon dioxide and water. You can note that, please. The products of the combustion of alkanes. The combustion of alkanes gives you 2 products, carbon dioxide and water. So that's it. If you're done, please put N as 2, get butane. No, put N as 4. Put N as 4, get butane, please. If you're done, put N as 4 here, get butane. So what do you get there? C4H8, H10, C4H10 plus what? Plus how many? 0.5? Okay. To give you what there? 4 CO2 what there? 5H2. But you don't use fractions, right? So what do you next there? Multiply by what there? 2. Multiply 2 by 2. Now balance out. In your year one, you don't use fraction. At that level, you start using fractions. So, but don't worry. Don't worry. Let's proceed. Let's do the last one, please. The last one on alkanes is called the pyrolysis of alkanes. Pyrolysis, also called cracking. When something cracks to a large extent, it will break up. Let's look at what is called the pyrolysis of alkanes. I said it means the cracking of alkanes. When alkanes crack or cracks, what's the product? All right, take down. Pyrolysis, if you're there, this is the last non-alkane, and we are done with alkanes. Pyrolysis is the decomposition of a compound by the action of heat alone. By the way, please, let me add this here, please. This happens under 600 degrees centigrade. So it's a very high temperature. So combustion happens at a very high temperature. For this one, is 600 degrees Celsius, by the way. Let me add it there. For this one here, for the combustion of methane, it occurs at 600 degrees Celsius. So it's a very high temperature that combustion occurs. All right, back to pyrolysis, please. I said pyrolysis is the decomposition of a compound by the action of heat alone. So hence, the difference between this and this is that for this, I need just heat alone. Full stop. The net result, paragraph, the net result of pyrolysis, the net result of pyrolysis is the conversion of a large alkane, to a mixture of a large alkane to a mixture of smaller alkane and alkene. To a mixture of smaller alkane and alkene. Smaller alkane and alkene. My pronunciation is good. Alkane, alkene, alkyne. Quite obvious. Said smaller alkane, A-N-E, and alkene, E-N-E. So I said, yeah. So a large alkane breaks down to a smaller alkane and an alkene. Example, you have this. So what do you have here? Check if this is balanced. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Balanced. Check hydrogen. 3, 4, 5, 6, 7, 8, 9, 12. 3, 3, 6, 3, 9, 10, 11, 12. So it's correct. What do I have here? 1, 2, 3, 4, 5. That becomes what there? 20. 5. I have a smaller alkane. What's this here? This is an ethane. Abi? 8 to ethane. What do I have here? 1, 2, 3. Prop 1 in. Prop 1 in or propene. Or prop 1 in. So observe that a large alkane having 5 carbon atoms, pent, have been broken down to a smaller alkane, that's X, having just 2 carbon, and then an alkene, that's this. This is called pyrolysis or cracking. A large alkane molecule breaks down to smaller one and then an alkene. So I have this. Also written as CH3 CH2 dot plus CH3 CH2 CH2 dot CH3 CH3 plus CH2 CH double bonded to CH2. So the idea is this: for your pyrolysis, see the way I wrote it down. So see the way they did it. See the way they did it. These two are the same. The products are the same thing there. But here's what they did to the reactant. They broke it down according to the alkane. What you should expect. That means this one means that I'll have an alkane that's having two carbon, as you can see here, and this one becomes the alkene. So they broke it down. This dot means these two should connect, and etc. All right. So please look up, please. This one here is supposed to be CH3. Yes, please. CH3. Of course, CH3. I have the CH3 and then CH this. So that's CH3, please. Oh, sorry. That's what you're asking, right? Okay. Okay. One more thing. One more thing. Said pyrolysis is the cracking of an alkane, a higher alkane compound to become a smaller one and an alkene under the influence of heat. So should you put heat here? Why not? Heat. Heat. Right, so that'll be it. Alright, so this is all about alkanes. We'll do alkanes in our next class. Or watch the video here.